Nothing's back. Tell a friend. Listening to a little Eminem here to get us started early in the morning on this lovely day. And I talk about it because today we're going to talk about motion and radio waves and simple harmonic motion. We call it simple because it's a basic introduction into it. We're not going to get too crazy into it, but it is how stuff like radio waves, TV rays, and the vibrating of a guitar string, that's how that all works. So it's pretty important to people like Eminem and the real Slim Shady or the real Brad Nunn. But before we jump into that, let's go ahead and get rolling into our review questions. So hit the pause button, give it a shot, see how you do. Welcome back. So I think we would all agree that this is a little bit bigger than 360 degrees. And the idea is saying, like, how many times bigger? So if you were to take this and divide by 360 degrees, you're going to get a little bit over 31. So what I would do is I would do 11,345 minus the 31 times it goes into it. And we're going to have a little bit left over. In fact, we're going to get 185 degrees. And that's going to be our coterminal angle. Okay? So you can have a positive one, which is the one we found there. You could also have a negative one. But since it didn't specify, we're going to go ahead and call the 135 and call it good. All right, the next one is 7 pi over 3. Now, once you look at this, you're like, Mr. Naughton, wait a minute, that was not on the unit circle. What's the dealio? And that's because it's over a full circle indeed. So just like the previous one that we talked about. This is the equivalent of saying 2 pi plus pi over 3. So I went in a full circle, hence the 2 pi, and then a little bit extra with that pi over 3. Okie dokie. So the only thing that's going to matter is my coterminal part, which is now the cosine of pi over 3. Now, if you know your unit circle, you're going to be happy to say that that's going to be 1/2, and you get to go ahead and move on. If you need to make your 60 degrees right there, and then you go, this is the root 3, this is the 1, this is the 1/2, and then you go adjacent over hypo, so 1/2 divided by 1, so it's still going to be 1/2. Either way, good stuff. And then last but not least, our range for this next one. Okay, remember range from our last videos is all about maxes and mins. So my midline here, if I just make a basic graph, my midline here is going to be at 2. So I'll go, there's at 2. Now, my amplitude is 4, meaning I'm going to go 4 above it. So 1, 2, 3, 4. So up here and 4 below. 1, 2, 3, 4. So 2 below our axis. So in this case, I'm going to go from -2 to 6. Alrighty. Now that our brains are pumped and ready to rock and roll, let's do some simple harmonic motion, or any motion that follows an up and down oscillating term. Oscillating. That sounds like sine and cosine. Yup. Hence why we're doing it right after sine and cosine, and then we'll go back and do tangent, cotangent, secant, and cosecant. Okay? So really this is our sine and cosine. So this is the application or the modeling part. Alrighty, so as I had talked about, anything that goes up and down, be a bobber on a fishing line or a guitar string, is going to follow these basic equations. So A cosine BT or A sine BT. Okay? So here are two equations, and they look very similar. So that A, that is still going to be your amplitude. So that hasn't changed. That's important. That D is going to be basically the displacement or the distance as we have right there. So how far above or below that midline we're getting. Okay. Then we're going to have T for time, as it almost always is. And then we're going to have our period. So again, this is going to come back to the sine and cosine. Okay. So we really take that B. Okay. And we're going to go ahead and do 2 pi divided by b, just like we have done, I feel like, a zillion times at this point. Okay? The next part of this is going to be the part that we're going to use, especially on the next page, is our frequency. So our frequency is 1 over the period. So frequency is equal to 1 over the period. Well, let's make this a little bit easier for us, since we know our period, as we just mentioned, is 2 pi over b. So I'm going to go 1 divided by 2 pi divided by b. So this is just a fancy way of saying divide. Alrighty. So then I'm going to get 1, well, I should say 1 over 1, excuse me, times the reciprocal of b divided by 2 pi. So that means that your frequency is equal to b divided by 2 pi. So right here you have a little space. I'm going to say frequency is equal to b over 2 pi. And that's going to make our lives a little bit easier, especially on the next page. Okay? But technically frequency is 1 over the period. All right, so this next part kind of tells us which trig function we're going to use, be it cosine or sine, and that's where it's going to start. So you kind of have to read these problems and decide, hey, am I starting at rest? So if I'm at rest, as in I'm right here on my midline and doing this, well, that's when we're going to use sine. Or am I starting this problem where I've actually pulled the either the string or the buoy or whatever, a value up. And so then it's going to go and do one of these. And that's, of course, when we're going to use our cosine. So we have to read these problems and decide what's going on and then move appropriately. Okay? But really it is, ladies and gents, it's all about the distance is equal to A times either sine or cosine BT. Okay, that's pretty much what it comes down to. Alrighty, so let's take our real life example. I'm going to erase this so we can read it all. So it says find an equation. That's good news. That means we don't have to solve for anything. Okay, which a ball that is attached to a spring hung from the ceiling. Okay, it is pulled down 7 inches. Now that's important. So let's go ahead and underline that. Okay, because when I pull that ball down 7 inches, I know that means you think that it starts at 0, but that means that the start is actually going to be right down here at a -7. Did I count that right? 1, 2, 3, 4, 5, 6, 7. Yep, there we go. Okay. Now, if you leave the ball right here, because some of you are like, well, wait a minute, you said you pulled it down. Here, there's no movement. So if I say it started there, there's going to be no movement. So that doesn't do anything for my lovely little string. It's as if I didn't play that lovely power chord. Okay, so that's why I'm going to go ahead and I'm going to say I'm going to pull it down, and this is going to be my start. And so when I pull it down, that means we're going to start at a max or a min. So in this particular example, I'm going to do cosine. And I've also found out what my A value is. Okay, so this is why we call it simple, because we're going to say if we ignore you know, stuff like friction, the weight of the ball, and some of these other things that are a little bit more complicated, gravity as such, again, it's simple, then what's going to go down is that the standard position is called the equilibrium position when D is 0 before you pull it down. Okay? Now, what was missing, and we have a little typo, is that here my time is 8 seconds. So we missed that in the directions there, but we want to just throw that in. So sorry about that. We'll work it in. We'll make the example a little bit better for next year, but since it's already copied, it is what it is. So what that means is that 8 seconds is how long for it to do a full rotation. So if we already know that our amplitude is 7, so 1, 2, 3, 4, 5, 6, 7. So the idea is we're going to go ahead and do one of these. This amount of time is 8 seconds. Okay, so our period takes 8 seconds. So remember, it's not that I'm just going to put the t here. I'm going to use that t to help me find out what my b value is, so I can finally write this all together. Because right now it stands, I have d is equal to -7 times the cosine of bt. So, ladies and gentlemen, we're going to take our b value, and that's going to be 2 pi over the time of the period. So the time of my period in this case is 8 seconds. Okay, so that's going to be 2 pi. Oh, I already did 2 pi divided by 8, excuse me. So let's reduce that down, so I'm going to get pi over 4. All right, so now I have the b value to plug it on in. So my equation is going to finish up being distance is equal to -7 times the cosine of pi over 4 times the time t. And booyah, Grandma, that's it. Alrighty, ladies and gentlemen, I love it. Alrighty. So, ladies and gents, we mosey on over to the next page of our notes here. We're going to have 3 examples, and we're going to find a couple of different things. We have A, B, C, D, so let's start with A. So that's the maximum displacement. That is going to be your amplitude. Remember, that's the absolute value of A. Okay, important. Then we're going to do the frequency. Now, we mentioned the frequency a little bit. Let's mosey on back over here. The frequency was 1 over the period, but then we said, hey, this formula is a little bit easier than having to do essentially all this every single time. So it's going to be B divided by 2 pi. So I'm going to write that over here to remind myself that my frequency, now sometimes they call that frequency a different value. We're just going to write it frequency like this since it's just kind of an introduction, and we're going to go B divided by 2 pi. Alrighty, the time required for 1 cycle, okay, that's going to be, remember, a 1 cycle is 2 pi, and then the time it's going to take for us to get there, which is what we're going to be looking for, and that's going to be equal to our B value. So in this case, to find that, what we're going to do is we're just going to solve for that time in the bottom. So we're going to put a t right there. And then the distance at time 0, okay? So the distance at time 0 is like your initial. So what is happening when you say the initial spot? Well, that goes back to what we said all the way over here in this point right here. Are you starting at the midline when sine is 0? Or are you at a max and min when you're using your cosine? Okay, so it really is just basically sine or cosine. Because that's going to tell you what's up. So, ladies and gents, number 1, let's give it a start. So I'm going to use purple here for this, for all of my amplitudes. So my A value here is that 8. So my amplitude is 8. Alrighty, my frequency. Again, that frequency is going to use that B term, which I've highlighted there in blue, which is pi. So frequency is equal to B divided by 2 pi. So in this case, it's B divided by 2 pi, or 1/2. Alrighty. Ladies and gentlemen, the time to make 1 rotation. So we're going to do that here in green. So again, it was 2 pi divided by the time t is going to be equal to my B value. So my B value in this case is still that pi. Should have put that B right there. All right. So ladies and gentlemen, I like to do this by cross multiplying because my t is in your denominator. So it's going to be pi times t is equal to 2 pi times 1. So then I'm going to divide both sides by pi. And it's going to take me 2 seconds or 2 minutes. I'm assuming it's going to be seconds here. Since if you ever seen a string, it moves pretty fast. So that's what we have right there. Easy peasy lemon squeezy. Last but not least is our distance at time equals 0. So that's cosine. So cosine meaning it's going to start up here, not at the midline, but up above. So because of my amplitude, this is at 8. So in this case, my distance at time 0 is 8. You don't have to make this diagram. It's just 8. Alrighty, number 2. Amplitude for the first part. Again, that's our purple. Now it's a -9. Remember, amplitude is always absolute value. So in this case, my A is going to be the absolute value of -9, which is just 9. Booyah. Check that one off the list. So then I'm going to need my B value for the next 2 parts, frequency and the time. So in this case, my B value is that 2. So frequency is going to be 2 divided by 2 pi. So that's my 1 over pi for my frequency. And then, ladies and gentlemen, to find my time, I'm going to use the B again. And it's going to be 2 pi divided by my time t is equal to my B value, which is 2. So I'm going to cross multiply. So 2t is equal to 2 pi. So in this case, it's saying pi is going to be my time. Fix my pi there. There we go. So about 3.14 seconds. And then notice we are at cosine again. And so I'm going to go ahead and say that it's going to start down here after my amplitude, which is 9. So technically this is -9. I'm a fan of distance always being a positive value. So I'm going to say my distance here at time equals 0 is 9. Okay? We just have to know it's in the negative direction. Alrighty, last but not least, why don't you guys give this one a shot? Hit the old pause button and then see how you did. Alrighty, amplitude here is 12. Easy peasy lemon squeezy. I'm going to go ahead and just go straight into distance since I'm looking at it and before I jump into my B value. My distance here, because it's sine, is going to be actually at 0 because it's going to be, for the first time, it's actually going to start on our midline because remember, the sign starts at your crosshair. So it's going to be at 0. All right, this is my B value. So for my frequency, I'm going to go ahead and do pi divided by 4, and then divide that by 2 pi. So I'm going to go ahead and go pi over 4, and then flip the denominator, so it's 1 over 2 pi. So then my pi's are going to cancel, so this is going to be 1 over 8. Again, pi's cancel, 1 over 8. All right, and last but not least, let's find that time. So we're going to go ahead and do pi divided by 4 is going to be equal to, sorry sports fans, I got to make sure that we actually set that one up right. So pi over 4 is equal to 2 pi over t. There we go. So I'm going to cross multiply here. And I'm going to get 8 pi is equal to pi t. So this, my time is equal to 8. All righty. Love it. Love it, love it, love it. So, ladies and gents, we got 2 more examples here, and then you're out the door. And both of these examples, you are going to go ahead and be writing the equation. So, ladies and gentlemen, again, we are looking for our d value is equal to the amplitude, sine, or cosine of bt. All righty. So, ladies and gentlemen, let's see what we can find as we explore. So, an object is attached to a coiled spring. It is pulled down. All righty. So that's going to go ahead and tell me a lot. That's going to tell me we're thinking cosine again. So I'm going to go ahead and write in my cos. It says the distance from the rest position at time 0 is 10. All righty. So that is my amplitude. I'm going to put an A right there. But remember, it is pulled down. So I'm going to put a -10 in there. So then, ladies and gentlemen, it tells me that it says the period is 6 seconds. Okay? So that means I need to find what my B value is to go right there. And then we'll have our time. So we're going to say, hey, my B is equal to takes a full rotation 2 pi, 6 seconds. So that reduces to be pi over 3. So I'll erase my B to make it pi over 3. Boom, shakalaka. All righty. Ladies and gentlemen, why don't you take this one for a spin? Did I wait long enough? If not, hit pause. Okay. So this one is going to be actually a sine one. Now that you had a chance to read it, it starts at rest and then begins bobbing up and down with a displacement of 11. Okay? So the idea is that I didn't pull it and then release it. It started to actually move. Okay? So I'm going to use the sine. As I said, my displacement here is going to be 11. So I'm going to put 11 in front of it. And because I'm going to go ahead and read into this a little bit, it says it goes up and then down. That means to me that my A value is going to be positive. Alrighty, and then we have our B value, which is that 1.5 seconds. So B is equal to 2 pi, and then I'm going to go 3 halves, because that's the same thing as 1.5. So 2 pi over 1 times 2/3 is 4 pi over 3. So then we'll do our 4 pi over 3 times t. So, ladies and gentlemen, that's it for today. Let's go ahead and review and make sure we're good. We talked about M&M at the start with our harmonic motion, talking about vibrating strings, radio waves, TV waves, and the like. Remember, it's either going to be a sine or a cosine graph. A is your amplitude, just like it was in our normal graphs. And then, excuse me, it is the same B value. And we had to go ahead and use our information to find out what B is in most cases by saying 2 pi divided by time. So if we want to write that right here, so B is going to be 2 pi divided by time. Not the worst idea either. All right, ladies and gentlemen, that's enough for today. I will see you in a couple of videos. Not now.